So this is a short question on probability. So let's read the question. An analysis was done on the effect of rain on the performance of a football team over 60 matches. It was raining on 24 of the days. They lost 35 of the matches. It was both raining and they lost on 14 of the days. And are the events of it being raining and losing a match independent? Explain. So this is about independent events essentially. Okay. So let's just sort of remark upon that. Now, what is the independent events? So independent events. The idea of independent events A and B is as follows. So if two events A and B, and if they're independent, A intersection B equals the probability of A times the probability of B. That's the idea. Now, so what we have here is we have three descriptions of events that have happened, or compound events, and what we're going to do is like sort of see if they reconcile. So let's actually on the sidebar here just make a few notes. So the first thing we were told is that it's R is for raining. That's the first of our events. Okay, and the probability of R is 24 divided by 60, and 24 divided by 60 is, let's write that down as, that's 40%, 0.4. Okay. The second event is that they lost the match, so lose match, and the probability of losing a match, P of L, they lost on 35 occasions out of 60. So again, a little bit of a probability calculation there, just a bit of simple calculator work, and we compute that to be just slightly less than 60%. It is, hang on a sec, 0.5833. So 0.5833. Lastly, we're told the probability of it raining and that they lose the match. So probability of R and L, or intersection L, is 14 divided by 60. That is equal to 0.2333. So 0.2333. Okay, so what we're going to do now is check if the probability of R and L is equal to the probability of R times the probability of L. And actually, we'll just work on the basis of, let's multiply this out and this out. And so the probability is 0.400, just put everything to 4 decimal places, and times 0.5833, and that actually does work out to be 0.2333. So we actually would say yes, independent. Are the events of it being raining and losing a match independent? Yes. So yes, independent. And the justification is that the respective probabilities obey the independent events formula. So that is the end of that presentation.